All right, Chapter 5, Problem 6. Got a team of 8 dogs pulling a sled on waxed wood runners on wet snow. The dogs have an average mass of 19 kilos each. The sled plus rider is 210 kilos. And they want us to calculate the magnitude of acceleration starting from rest if each dog exerts an average force 185 newtons backwards on the snow. So, first, what is the force of the dogs, right? Force of the dogs is 185 newtons times how many dogs we have? 8 dogs, right? So the dogs, 185 newtons times 8, so 1480 newtons. All right, so we have 1480 newtons from the dogs. The force of friction, right? Force of friction is due to what? So kinetic friction is mu k times the normal force. The normal force in this instant is the weight of the sled, which is 202 kilograms, times the acceleration of gravity, 9.8 meters per second. Oh, let me write that as 9.8 meters per second squared. All right, 202 kilograms times 9.8 to 10 times 9.8. So the normal force is 2058 newtons. Okay. And then the coefficient of friction between waxed wood and wet snow. All right. Waxed wood on wet snow, kinetic coefficient of friction is 0.1. So mu k equals 0.1. All right, this means the frictional force is 0.1 times 258 newtons equals 205.8 newtons. All right. What's the net force then exerted on everything? The net force is the force of the dogs minus the frictional force. All right. Force of the dogs minus, so 1480 newtons minus 205.8 newtons. So that's 1480 minus 206. 1480 minus 205.8 comes down to 1274 newtons. That's the total net force. Now they want us to calculate the magnitude of the acceleration. The reason we're getting all of this is what we're after is the net force equals mass times acceleration. All right. So what is the mass that we're accelerating? The total mass that we're accelerating is the sled plus the rider plus 8 times, how much is each dog? Each dog is 19 kilos. All right? So 210 plus 8 times 19, 210 plus 8 times 19 is 362 kilos. So we've got a mass of 362 kilos. We have a net force of 1274 newtons. That means the acceleration equals which equals the net force divided by the mass, is 1274 newtons divided by 362 kilos. All right, 1274 by 362 is 3.52 meters per second squared. 3.52 meters per second squared. And that's the acceleration in part A. All right. Except what I just calculated was the magnitude of the acceleration in part B. All right, part A, the only difference is This is part B because this is kinetic, right? And they want also for us to look at mu s. Mu s is for wax width 0.14. 0.14. And that means Fs is 0.14 times 2058 newtons equals 0.14 times 2058 is 288 newtons, right? And so the F net before you start moving is the 1480 newtons minus 288 newtons is newtons minus 288, 1192 newtons. Relabel this part A up here. All right, so 1192 newtons, and then we're back to F net is MA. Over M is 1192 over 362 kilograms. 362 kilos is 3.29 meters per second squared. So this is the initial acceleration, but as soon as you start moving, it becomes this, which is why I didn't bother calculating that part, and I hadn't read closely enough. So before it moves, or just when it starts to move, the initial acceleration is 3.29 meters per second squared. But as soon as it starts moving, you're into the kinetic friction case, and then the acceleration is 3.52 meters per second squared. For both situations, calculate the magnitude of the force in the coupling between the dogs and the sled. Okay, magnitude of the force in the couplings between the dogs and the sled. So for part C, if you think about the coupling between them, you've got the dogs, right, pulling this way, and they're pulling for, let's start over on that. The dogs are pulling how much? 1480, right? Okay. So you got the dogs pulling this way on the coupling at 1480 newtons, and then in one case you've got friction pulling this way for 205.8 newtons or 206 newtons. That's once you're going. Before you're going, that number is, I believe that number was 288 newtons, right? So what's the total force on the coupling? Well, the coupling experiences this plus that, right? So the coupling experiences a greater force. So for one part, we have the coupling is 1480 plus 288, and for the other part, we have the coupling is 1480 plus 206. So F1, 1480 newtons plus 288 newtons. 1480 plus 288, plus 288, 1768. And in the second case, it's 1480 newtons plus 206 newtons, right? 1480 plus 206, 1686 newtons. And that's it for this problem.